Welcome to day 11 of our CT review. Question 1 asks us to use the Pythagorean theorem to find the unknown. Round answers to one decimal place. So here in question A, we're asked to find the hypotenuse, and we're given two sides. So we can say that x squared equals 6 squared plus 4 squared. X squared equals 36 plus 16. Therefore, x equals the square root of 52, giving us a final answer for x of 7.2. In question B, we're given a side and hypotenuse and asked to find the other side. So we can say that x squared plus 8 squared equals 10 squared. X squared equals 100 minus 64. X squared equals 36. Therefore, x equals the square root of 36, giving us a value of 6 for x. Label the sides of the triangle with the words opposite, adjacent, and hypotenuse, using angle B as a reference. Well, we'll do that since B is the reference. This is the opposite. This is the hypotenuse because it's opposite the right angle, and the remaining side is the adjacent. So we can say that the sine of B equals opposite 5 over hypotenuse x. Cross multiplying. Sorry, they're not asking for us to actually solve it here. They're simply asking us to state the ratio. Well, the ratio that has to do with opposites and hypotenuse is the sine. So we can say the sine of B will equal 5 over x. And that's all the information we have. We don't have enough information to continue to solve for the angle or for x. Evaluate to 3 decimal places the cosine of 34 degrees, the tangent of 67 degrees, and the inverse sine of 0.5 degrees. Given triangle DEF and reference angle E, which trig ratio is represented by the ratio 2.4 over 3.9? So here's our reference angle, 38 degrees. If we label it, that would make this side opposite, and this side hypotenuse. So opposite over hypotenuse, according to our trig ratios, is the sine trig ratio. Finding sides using trigonometry. So let's fill in this chart. Let's figure out what our reference angles are, what we're given, and then decide which trig ratio we're going to use. So our reference angle is 41 degrees. We're given, relative to the reference angle, the opposite, 40 centimeters, and our unknown is the hypotenuse, which we'll call x. So the trig ratio that deals with opposite and hypotenuse is the sine. So we'll use the sine trig ratio to calculate this. So we can say that the sine of 41 degrees equals opposite 40 over x. Cross multiplying to solve, we can say that sine 41x equals 40. And if Sine 41 times x equals 40, then x by itself equals 40 divided by sine 41. We'll put that into our calculator, and that will give us a value of 61. In this question, our reference angle is 60 degrees. We're given the hypotenuse of 25, and we're asked to solve for the adjacent x. So the trig ratio that deals with adjacent and hypotenuse is the cosine. So our trig ratio is going to be the cosine. So we can say that the cosine of 60 equals adjacent x over hypotenuse 25. Cross multiply, x equals 25 times the cosine of 60. X is 12.5. In this question, we're asked to find an angle. In this case, we're asked to find the reference angle A. We are given two sides. So relative to the reference angle A, we are given the hypotenuse at 7.1, and we are given the adjacent of 6.3. The trig ratio that deals with adjacent and hypotenuse is the cosine. So we can say that the cosine of A equals 6.3 over 7.1. Now we want to know the angle A by itself. So if the cosine of A equals this fraction, then the angle A equals the inverse cosine of this fraction. And we put these into our calculator, and it returns a value of 27 degrees. In this question, we're given a reference angle 42 degrees. We're given the hypotenuse of 4.9, and we're asked to solve for x, which is the opposite to our reference angle. The trig ratio that deals with opposites and hypotenuse is the sine. So we can say that the sine of 42 equals opposite x over hypotenuse 4.9. Cross multiplying, we get x equals 4.9 times the sine of 42. X equals 3.3. To find this distance AB across the pond. So here's A, and here's B down here. It's a little bit difficult to see. Measure the distances shown. Use these distances to calculate the distance of AB. So what we have right here are two similar triangles where the ratio of the smaller triangle here has a ratio of 25.7 to 63.0. So what we want to know is, what is the ratio of this unknown distance to this distance 22.5 plus 63.0. So we can set up an equation that looks like this. X, which is the distance we're trying to figure out, over 25.7, which is this distance right here, equals 63 over this entire distance right here. And once we have this equation, then we just need to do a little cross multiplication and solve for x. And that results in a value of 34.9 meters. A 1.8 meter tall person casts a shadow 2.4 meters long. At the same time, a tree casts a shadow 4 meters long. how tall is the tree? Well, the whole basis for figuring out this question is to rightly assume that the ratio of a shadow to a person is going to be the same as a shadow to a tree. So we're simply setting up a ratio here. 1.8 over 2.4 equals x over 4. We do some cross multiplication, solve for x, and end up with a value of 3 meters. So the tree is 3 meters high.